There is no dawn or dusk on this journey. The seasons do not change, the sky does not shift, and yet life flows uninterrupted within a colossal vessel crossing the silence of the cosmos. In a generation ship, time is measured not in days but in bloodlines. The stars remain fixed beyond the windows, distant and unreachable, while inside births and funerals, loves and betrayals, wars and peacetimes follow one another, as in any other society. But here, the entire world is enclosed in a metal shell kilometers long, launched on a one-way voyage toward a planet the first passengers will never see. The reason behind this apparent madness is simple. Interstellar space is vast, and even the closest destinations require timescales far beyond a single human life. Proxima Centauri, the nearest star, lies over 4 light-years away. With current technology, such a trip would take tens of thousands of years. Generation ships circumvent the problem by turning the entire crossing into a multi-century process. You do not depart to arrive. You depart so that your descendants may. From an engineering standpoint, a generation ship is a colossal-scale space habitat. A pressurized shell is not enough. A true miniature biosphere is needed. To simulate gravity, the most realistic solution is rotation. Cylinders at least 500 meters in diameter rotating at about 1 to 2 revolutions per minute to generate centrifugal force equivalent to Earth's gravity, without causing nausea or disorientation. Some theoretical designs, such as the famous O'Neill cylinder, envision structures several kilometers long with interior landscapes, hills, lakes, farms lit by artificial suns. The issue of sustainability is crucial. Every molecule must be reused. Water, oxygen, and nutrients must circulate in a closed loop, like in a terrestrial ecosystem, but without any possibility of outside help. Experiments like Biosphere 2 have shown just how difficult it is to keep such systems stable. Even minor variations in gases or nutrients can lead to dangerous imbalances. On a generation ship, this margin for error simply does not exist. Every resource loss is a death sentence. The ship's beating heart, its energy, could come from nuclear fusion reactors, theoretically able to operate for centuries with minimal fuel, or from hybrid systems combining solar sails, high-capacity batteries, and electric impulse engines. Some futuristic ideas suggest inertial confinement fusion drives or matter-antimatter propulsion, but for now they remain unrealized concepts. What is certain is that a traditional chemical engine would never suffice. Its mass-to-energy ratio makes it entirely impractical for such distances. The ideal cruising speed would be a fraction of light speed, around 0.1 to 0.2 c. This would allow travel to star systems a few dozen light-years away within a few centuries. But speed is not everything. The faster you travel, the greater the risk of collisions with interstellar debris, whose kinetic energy at such speeds would be catastrophic. This is why designs include multiple shields, dust barriers, or magnetic fields to deflect charged particles. Yet if technology is the first obstacle, the true test lies in the society on board. On a generation ship, the very concept of mission risks dissolving over the generations. The grandchildren of the first settlers may feel no connection to the destination planet, and the risk of cultural fractures is immense. Some scholars propose extremely rigid educational systems to keep the memory of the voyage alive. Others imagine semi-theocratic governments where the mission is almost a religious dogma. Even with well-structured laws and culture, there remains the biological problem. A small population risks falling into genetic bottlenecks. The most cautious estimates speak of at least 2,000 to 5,000 initial individuals, supplemented by genetic banks and frozen oocytes to introduce new variability. Failure here would not only mean hereditary diseases but an entire community doomed to sterility within a few centuries. To all this, one must add an often overlooked element: the psychology of a journey without a horizon. Living with the knowledge that one's entire life will unfold within artificial walls, never seeing a true sunset, could generate chronic depression, apathy, and even collective behavioral disorders. To counter this, the most advanced designs envision highly varied habitats, miniature forests, grassy hills, artificial lakes beneath simulated skies whose light and color change as if influenced by a sun. Some sections of the ship could host different climates, recreating artificial seasons to maintain a sense of variety and cyclical life for the inhabitants. The very management of time would become a cultural factor. In the absence of real day and night, the entire community would follow a calendar synchronized by central lighting and ambient sound systems. This collective clock would serve not only to regulate biological rhythms but also to mark festivals, rites, and traditions, preserving social cohesion. On the technological front, maintenance would be a perpetual task. Every component of the ship would need to be repairable and replaceable with internal resources, implying an onboard industrial capacity almost equal to that of a small nation. Factories, laboratories, workshops, greenhouses, and research centers would have to operate in synergy, creating a completely autonomous supply chain. Even housing structures would need to be modifiable and convertible depending on demographic changes. A population increase would require more residential space, while a decline could free up modules for agriculture or research. The danger of catastrophic failures is ever present. A fire in an agricultural module, a structural collapse, or a malfunction in air filtration systems could have devastating consequences. This is why designs include extreme redundancy, multiple separate habitat modules, connected but isolatable, and emergency vehicles able to temporarily house hundreds of people. Some scenarios even include small independent daughter ships, ready to detach and continue autonomously if the mother vessel became uninhabitable. The interstellar journey of a generation ship is not only an engineering and biological challenge but also a philosophical one. It would mean creating a new culture that sees the ship itself as its world. No longer merely a means of transport, it would become homeland, heritage, and religion. From this perspective, the mission would lose its transfer nature and become a permanent condition. Descendants might even choose never to land on the destination planet, instead continuing to travel. The boldest speculations imagine fleets of generation ships crossing deep space, exchanging technologies, resources, and even individuals, like mobile archipelagos of nomadic civilizations. In such a scenario, humanity would not simply colonize a planet. It would become a truly itinerant interstellar species, with ports and routes among the stars. Naturally, the risk of failure is immense. A generation ship could get lost, veer off course, or simply cease to function. Yet even in failure, such an attempt would leave an invaluable legacy: technical knowledge, biological adaptations, new forms of social organization. It would be an irreversible step toward humanity's transformation into a civilization able to live anywhere, even in the eternal void. Although today the concept of a generation ship still belongs to the realm of theory, it did not arise in a vacuum. Its roots lie in 20th-century science fiction, when writers and scientists began to grapple with cosmic distances. In 1941, Robert Heinlein published the short story, Universe, in which an entire community lives aboard a ship so ancient that its inhabitants have forgotten its true nature, mistaking it for the only existing world. This theme, the loss of historical memory and the creation of myths to explain the surrounding environment, has become a narrative cliché, but with good reason. In a centuries-long voyage, oral tradition and religion could easily transform the original mission into legend. Arthur C. Clarke and Ursula K. Le Guin also explored similar scenarios, imagining closed societies developing their own politics, economies, and even languages. These works of fiction, despite their creative license, anticipate real problems space sociology must face. How to prevent scientific knowledge from deteriorating. How to avoid power concentrating in a few individuals or groups, turning the ship into an authoritarian regime. Another frequently discussed point is the issue of initial resources. Outfitting a generation ship would require an unprecedented logistical and industrial effort. Just building the outer shell could require millions of tons of material, likely extracted from asteroids and moons in the solar system, to avoid the prohibitive cost of launching from Earth. Internal habitats would need to be built from light but resilient alloys, and agricultural systems would need to be designed to provide not only calories but also dietary variety and essential nutrients. Imagining generations growing up eating the same few crops is unrealistic. Dietary monotony could have psychological effects as harmful as nutrient deficiencies. Technologically, some theories point to a hybrid between a generation ship and a hibernation ark, where part of the population would travel in cryogenic sleep, awakened periodically in rotation. This would reduce resource consumption and allow a smaller active population, but human hibernation technology is still far from feasible. A malfunction in the maintenance system during cryosleep would be fatal for all passengers in that state. There are even more radical proposals, transporting not physical bodies but information. A digital generation ship could carry genetic and mental archives along with autonomous robots capable of reconstructing human beings and entire societies on the destination planet. In this scenario, the ship would essentially transport humanity's memory, ready to be reactivated in a new world. However, this raises profound questions about identity. If the recreated individuals are not the same as those who departed, can we truly say it is the same mission? The external environment is no less dangerous than the internal one. Over a centuries-long journey, the ship could pass through regions of space with intense radiation, such as supernova remnants or unstable gravitational fields. Shielding from cosmic radiation requires considerable material thickness. Meters of water or lunar regolith have been proposed, and a miscalculated route could lead into zones where even the most powerful shields would be insufficient. Some designs include artificial magnetospheres to deflect charged particles, but maintaining a stable, powerful magnetic field on a kilometer scale is a colossal technological challenge. Perhaps the most fascinating point about generation ships is not technical but conceptual. They represent a paradigm shift in the idea of home and homeland. For fourth or fifth generation inhabitants, the ship would not be a vehicle but their only known universe. Planets like Earth or the final destination would exist only in stories and historical records. For them, the concept of end of the journey might be entirely alien, and it is not inconceivable that, upon reaching the destination, they might choose to keep traveling forever, turning the mission into a cosmic nomadic tradition. Ultimately, the generation ship is an idea as old as the first human voyage into open sea, setting sail toward the unknown in the hope of finding a better land. Only this time, the sea is made of stars, and the waves are of emptiness and radiation. Whether the dream comes true or not, imagining it forces us to rethink who we are, what we are willing to sacrifice, and how we will define, in the future, the word humanity. If you have made it this far, it means you love curiosity as much as we do. If you enjoyed this journey, leave a like, write a comment, and subscribe to the channel. It is the best way to support what we do. Your presence truly makes a difference. Until the next exploration.